I wasn't lying when I said that. Let's share screen. God, look how far we've come. There we go. Look how fast that was. Oh, I can fix this. Fixed. Okay, so let us talk about, before we talk about functions, which what the real topic of today is, we need to talk about power sets, because I totally forgot to cover that last week. We're talking about sets. It's the last little bit of sets. There are so many parts of sets. There's so many different avenues it goes into. And it bums me out because we don't really go that deep into any part of it. We're just going to go into the shallow end. That's okay. This is how you learn things. This is how you start the class. So this is going to be briefly, this is actually in chapter, nope, we don't have chapters. We don't have chapters, Daniel. This is going to be in section 6.1, and it is power sets. All right. And so to give it a definition, the power set, so the power set is a way that we build a set from the subsets of another set. It sounds really weird. So the powers is the definition. The power set of a set A, so A is a set, is the set of all of the subsets of A. So this sounds confusing. It's the set of all the subsets. And the thing to think about is just that if you think about set theory, which we've been going over so far, you have a set, and the only really things we know to do with that are we can combine them, make new sets, but in terms of like going the other way, just seeing what's inside of A, like we can combine them to make bigger sets, but to make smaller sets, the only thing we really know how to do is take subsets. And the power set just keeps track of all those subsets, which is kind of an interesting thing. So for example, the power set of the set A, B, 5 is going to be the set of all the subsets of A, B, and 5. So let's see. I mean, what's a subset of A, B, 5? You could have A, right? A itself is a subset. It's a set built from A, B, and 5. You could have B. You could have just a set of 5. All these are subsets. But you can also have AB, right? It's a subset, right? With 2 elements. You could have A5, that's a subset. Or you could have B5. Am I missing any? Or are these all the subsets?
The empty set, right?
The empty set. Actually, that was the second one I was hoping you forget that one. Yeah, the empty set's perfect. We need the empty set just because the empty set, remember, is a subset of everything. I mean, when we write it like this, it kind of makes sense. Like these are all the subsets of 1 element. These are the subsets of 2 elements. What about the subset with 0 elements? That's always the empty set. It's at the intersection of all the power sets. Very interesting. Anyway, though, what else do we have?
You need A, B, and 5, right? The 3 elements.
Exactly. The whole thing. Now, this is a proper subset, but it is a subset. It's a set built from just A, B, and 5. And then we have to put the curly braces on all of this because it's the set of all these things. It's the set of all the subsets. So this is the power set of A, B, and 5. Kind of neat. It's just the set of all the subsets. And one thing you can note here, I'll say note, that the size of this these bars, we'll go over them like tomorrow more. These bars indicate size. The size of this set is 1, 2, 3, 4, 5, 6, 7, 8. We'll note that for later. That's another one. That's an even easier one. Let's do the power set of, let's see, the set of the matrix 0, 1, 1, 0, and pi. So if we go through, I kind of noted we're going to need the empty set because we're going to need the set of zero, the subsets with just 0 elements. And if we look at all the subsets with 1 element, we'd have, well, we just have 0, 1, 1, 0, the set of just this guy, or the set of just pi. We also need the set of them together. So these are all of the subsets that you can make from 0, 1, 1, 0, this matrix, and pi. It doesn't even matter if you don't know what a matrix is. The point is it's just an element, it's a thing. And so we need to take the set of these. And then I'll note up here, note the size of this. Equals 1, 2, 3, 4. Any questions on how we got this? Okay, so next, let's go even smaller. Let's look at the power set of just one number, like lucky 13. Uh-oh. You know what blew my mind when I was a kid? That some skyscrapers or like buildings, they don't have a floor 13. I mean, they do. They just label it 14 and they go on like nothing mattered. It still gets me to this day. But anyway, what are the subsets of just 13? What do we got?
Just empty set and 13.
Exactly, Afra. Exactly. Perfect. Same set 13. These are the power sets of the set 13. The set just 13, just here. And we should note that the size of this set equals 2. All right. Now I have a question for you guys. And the question is, how many elements will the set, or will the power set -1, 0, 1 have? If my computer sounds like a cow mooing again, I apologize.
8.
Yes. Why 8, Afra?
2 to the power 3 equals to 8.
Oh, Afra read ahead, it looks like. Yeah, that's true. I'm going to get to that. But more importantly, what I want to look at on the board here is our set of AB5, the power set of that, had 8 elements. And we should notice here that the specific elements we used here, it doesn't matter. Like if we actually looked at the power set of -1, 0, 1, right, we'd have the empty set, and we'd also have -1, we'd have 0, we'd have +1, we have the set -1, 0, -1, 1, 0, 1, -1, 0, 1, like this. But notice, this is directly analogous to this set right here. You have the empty set, A goes -1, B goes to 0, 5 goes to 1, AB goes -1, 0, A5 goes -1, 1, B5 goes to 0, 1, A5 goes -0, 1, -1, 0, 1. Like, these two are exactly the same. I mean, the elements are named different things, but really, if you look at it, the power set of anything with 3 elements is going to look basically the same, just relabeling the elements whatever they happen to be. The point being, the math fact, is the size of a power set has nothing to do with has nothing to do with the elements in the underlying set, with the type of elements, I should say, just the size of the underlying set. Oops. Does that make sense? So every set with 3 elements will have a power set with 8 elements. You see why that matters? Because it has nothing to do, like the fact that this is A, B, and 5, the fact that this is -1, 0, 1, it never came up. It has nothing to do with how we create the subsets. And it's only the structure kind of these sets. It's kind of like I have 5 fingers in this hand and 5 fingers in this hand. So I have 5 plus 5, 10 fingers overall. But if I had like 10 markers here and 10 markers here, or 5 markers here and 5 markers here, and I add them, I would have 10 markers. Like the underlying math there was the sign. 5 plus 5 equals 10. Like the things I was adding doesn't matter. Exact same thing here. Like the particular things you're taking the power set of doesn't matter. It's the structure of how many there are. Any questions on that?